All right, and we're live. So welcome back to another week of You Don't Know JS, or Reading You Don't Know JS. Yeah, that's the name of it. We are starting on book 3 this week. We're going to be covering chapters 1 and 2. Let me go ahead and bring up the slides.
I'm glad we only did the 2 chapters, though.
I'm very glad we only did the two chapters. I don't think I would have gotten to the third one.
Yeah. Well, and it would have made for a really long night tonight, too, because I think chapter 3 is kind of a beast. It may be its own week.
Yeah, if it was anything like these first 2 chapters, then I think that would be good. Oh, speaking of which, I'm not going to be able to make it next week. I don't know if you want to postpone a week and come back, or
let's push it. I've got stuff that I have things going on next week as well, and I was going to try to make it, but if you're not going to be available anyway, we could just push it. That's not a problem.
Okay, yeah, let's go ahead and just plan on pushing it out a week. Cool. All right, well, let's go ahead and get started. Can you see my screen?
Yes.
Awesome. How do I... There we go. Okay, full screen. So chapters 1 and 2 of book 3. Book 3 is called This and Object Prototypes. Chapters 1 and 2 pretty much were just talking about the this keyword in JavaScript, and this is quite confusing.
I think chapter 1 is basically what this isn't, and chapter 2 is how this works.
Yeah, I think that's a good explanation.
That was basic.
Yeah, I thought that was kind of confusing though, the way it was. It was like, so I just read a chapter on what I'm not learning about. Okay.
Right. Yeah, I kind of think that I don't agree with him. I felt like the first chapter should have come after the second.
Yeah.
Because it seemed like it was a lot of like, well, let me tell you what it's not. It's not this, and it's not this, and it's not this. But if I don't have the context for what it kind of is, I'm not going to get a lot. Yeah.
Yeah, I agree.
So we could try to do that. Well, let's go ahead and try to do it in the order he did it tonight. But I think it might be a good idea to, even after we cover the last half, to maybe refer back to some of the stuff in the first chapter, because we'll understand it.
That's a good idea. That might be interesting, because I think it'll make more sense that way. This is a very interesting concept. I haven't seen something like. I really hate referring to it as this, because it sounds like I'm talking about something else. But the concept of this in JavaScript is not something I've seen used. How do I say this without saying the word this? It's not something I've seen in other languages.
So other languages that I've worked with, of course, Ruby has the concept of self.
Yes.
But self is always an object.
Referring to the object that the code is in.
Yes. Yes, that's right. Yeah. I think so.
I think so. I could be wrong, but I
haven't gone into a deep dive on what self is in Ruby before. But self always seems pretty intuitive to me in Ruby, unless you start getting into some of the really weird, like having classes instantiate classes in Ruby. When you start build, like when I wrote the urgem, the urgem has classes that initialize other classes inside of themselves, and
so this could be referring to something that doesn't necessarily seem intuitive.
Right. And when at least with self, there were some times when I lost track of where self was when I was writing the code, and I had to kind of capture self and store its reference. So yeah, some of the things that this talks about, Ruby can get into the weeds with this stuff too with self.
Okay.
But I'm not sure what the difference is between the two in the different languages. Yeah. Except that, yeah, there clearly are differences. They're not the same thing.
Right. Yeah, exactly. Yeah. Let's get started.
Yeah.
Okay, so I got some links here. If anyone's out there and watching wants to catch up on episodes or wants to participate in the Hangout, then there's some links there. Go there and you can either sign up or watch some stuff. I left book 2 scopes and closures at the top, but I substitute out the image and the links. That's supposed to say book 3, this and object prototypes. So if you want to buy the book, it's there. Otherwise, you can read it online. And
you
chapter
didn't
1.
copy and paste over your old slides and just rewrite them again, did you?
No, I just got really confused about what book it was. Okay, so chapter 1, this or that. This is confusing. One of the most confused mechanisms in JavaScript, or confusing mechanisms in JavaScript is the this keyword. So this, it's a special identifier keyword that's automatically defined in the scope of every function. So it's going to exist in any function in JavaScript, and JavaScript will define it in a way that we're going to be talking about. The book says that this is more misunderstood than confusing, that there are some rules behind how this is used, but
Right.
it's not necessarily intuitive. And because of that, it can seem magical because of your confusion. So let's see if we can make some sense of this.
Okay.
You'll see plenty of this puns up at the top because it's just so easy to use the word this in a sentence. So what's this all about?
So let's see, we have an identify function that calls this.
Mm-hmm.
We have a speak function that says identify. It calls identify and passes a this to the call.
Mm-hmm.
We have a variable that's an object of
Kyle.
me, and we have a variable of an object of you.
That's right.
Identify.call me, identify.call you. Okay, that all seems pretty straightforward.
Okay, yeah, and so when we pass me into identify, it's going to uppercase the name, which seems kind of intuitive here because we're saying uppercase the name of this, though it's not necessarily clear what this is referring to at this point. But but you do get an uppercase value back, which seems to make sense.
So like I'm passing an argument in, that sort of makes sense, but it's going to use the argument that I pass in the call function.
Exactly.
Yeah,
even though there's no defined argument here on that.
Yeah, but you're using a call. You're using a call function, so that sort of to me seems like there's some kind of like the identify block is expecting me to pass.
Okay.
When I call, it's going to treat me as the variable.
Interesting. So maybe it's because like your familiarity with Ruby, and I guess Ruby has some stuff that does that kind of thing.
Kind of, yeah, it does. Definitely does. Yeah.
Okay.
Ruby has lambda
and
proc, which are very similar to this kind of behavior. Yeah, and you do like .call methods.
Okay. Cool.
To call the proc. Yeah. I actually was playing around with it some today.
Oh, nice.
Kind of, just after reading this, I watched just happened to be watching a talk on metaprogramming that actually was showing how to do prototype inheritance in Ruby.
Really?
Which is something we will be getting to next week. Yes. So I'll probably do the slides for next week, and I'm going to show some examples of what it looks like in Ruby to give you a better idea of how it looks in JavaScript.
Hey, that'll be interesting. I'm curious to see how that looks because I don't really understand prototyping objects.
Yeah.
But I think
I didn't even know prototype inheritance was something you could do in Ruby until today, and now I'm like, now I understand what it's doing in JavaScript a lot better.
Okay, cool. Okay, so here's our code that we looked at on the last screen. So this allows you to pass context to functions implicitly. Implicitly meaning that we don't have to actually pass it explicitly through the parameters. Right.
That's what the call is doing. It says like .call, and I'm passing you an argument, and you're implicitly taking. You're going to assume this is just going to assume that when you do .call on it, it's going to get an argument.
Exactly. So implicit parameters like this can be preferred in JavaScript, but if you were to write something kind of similar to this, here's an explicit way of writing it. So it's not exactly the same. The code's a little bit different, but you kind of get the same idea.
This is more what I'm traditionally used to as far as like, if you're treating functions like methods in Ruby, if you're treating functions like methods in Ruby, this is a lot more like what you see in Ruby. The explicit. You have a named argument. You tell it to do something with a named argument that it expects to get passed in. But I could totally see why the implicit can be useful after having messed around with metaprogramming some.
Okay.
Yeah.
So because you don't have to define explicitly what you're passing, or is there another?
Because you can do things like you can write code that writes code.
Okay.
With the implicit stuff, you can set it up so that it, like, because of closure and things like that, you can have it set up. You can set up like function builder functions that will let you like dump a whole bunch of functions out very quickly with just a few lines of code.
Oh, interesting. You can do that in JavaScript too?
I would assume so. If you can do it in Ruby and you have closure and this kind of like self-referential stuff like we're getting into, there's no reason why you shouldn't be able to do it in JavaScript as well.
Okay, cool.
Yeah.
Okay, so now, like you said a little earlier, now we kind of dig into how this does not work.
Right.
So the first way that this does not work is that this does not refer to the function that it is in. So if we're considering an example here, so we got function foo, it's going to write out to the console foo, and then the name of this parameter, or the value of this parameter num. And then it's going to look at this, and which we might think is referring to function foo.
Right.
And increment a counter on it. And then so we set foo dot count, that counter equal to 0. We initialize it to 0. We get this variable I. We set up a loop, and it's a loop from 0 to 9. And if I is greater than 5, then foo I. So we might expect 6, 7, 8, 9 to come out, and that's what we're seeing here, is that 6, 7, 8, 9 is printed to the console. But when we go and look at how many times foo was called by checking our counter, we get 0.
Yeah, it was never incremented.
Exactly. So,
and if you actually do like a if you call like count, if you just do like count semicolon, I think it'll return 4.
I think you're right.
Or 3. Yeah. 4. 4.
I think it's 4.
Yeah. Return 4.
I think you're right, because it does get into.
It creates a global variable.
Exactly. This is, in this case, referring to the global object.
Right.
Here's for comparison how we could write this code so that it does do what we would have expected this first code to do. It's very similar, except that in this case we're creating this object data instead of this keyword, and you'll see that it comes out as 4.
Right, and the data.count still exists on the global level. It's the same. It's just instead of being assigned to the global object, it's assigned to something that we're actually keeping track of. And
exactly.
So it's more explicit.
Exactly.
But the code's doing the same thing.
Yes. Yeah. Okay, here's another example. This is that same code that we had in the first half before.
Yeah.
Now we're going to compare it to this one here. So in this case, we've got function foo. This all looks kind of the same, except that in this case, we've got foo.count rather than this.count. And we run through, and this works correctly, because in this case, we are, in fact, referring to function foo. You can see pretty clearly that this is not the same thing as foo, because this code is pretty much the same thing apart from
Exactly, yeah. So no, that's a good example of how self is not a reference to the function that it's in. It's a reference to the object at the location that the function was called.
Exactly. So the second way that this does not work is that it does not refer to the function's lexical scope. So let's look at an example here. We define this function foo. We set a variable a equal to 2 within this function, and then we call this dot bar. So this dot bar, I'm sorry, function bar. I suppose this would probably get hoisted in any case.
No, it doesn't. It breaks in 2 different places.
Oh, okay.
Yeah. Because because I don't know. It definitely breaks because there's no a inside a bar.
Right.
Yeah, I don't know. That does. Yeah, that doesn't work. It definitely doesn't work. It's not lexical scope.
Yeah, exactly. It's not. We're not tying. This isn't referring to this lexical scope.
Yeah. So for example, we can do this. Since we do know, we can think ahead a little bit. We do know that this is scoped to where it's called, right?
Yes.
But that's the surprise that's coming at the end of the chat, at the beginning of the next chapter. So function foo, this dot bar, this is scoped to foo. And so there is no bar defined inside of foo. So it blows up there.
Yeah, this is global scope that is looking for bar, though. And
it's looking for bar inside it because it's calling this dot bar for the purposes of foo. So I think it's going to blow up. Like if you just take the foo call down, like if you make console.log like pretty ponies, or whatever instead of this .a, it's still going to blow up. I'm pretty sure because the bar call is saying the bar. I don't think it's so this says it's this where it's scoped to. And since there's not a closure there, there's no bar within the closure, I think it's going to blow up.
Okay.
I guess we could try it.
Yeah, let's give it a shot.
Let me try it real quick here. Let me hit. Oh, yeah. Right, you can do it because you're already sharing screen.
Yeah, let's see. So what am I doing? Okay, so if we say, where did my slide go? Why am I on?
Okay. Here, I'll share my screen and I could, well, that won't work either because then I won't be able to see your slide either.
Okay, so we go to console here.
We say function foo. Can you copy that?
No, it's a picture.
Here, I've got it. I've got the code right here.
Okay.
Let me pull mine up and share my screen. I'm going to copy and paste the code. It's the, let's see, it's going to say undefined, right?
Are you sharing your screen?
Not yet. I'm getting the code first. And then I'm going to share my screen.
Okay.
Yeah. Okay. Copy. Boop, boop, boop. Am I sharing?
Yep.
Okay. All right. So we got, so I'm going to paste the code in, and then I'm going to edit it. So we're going to make this .a just say hello. and then we're going to call foo and see what happens, okay?
Okay, sounds good.
Hello. But it does work. It does hoist var.
Okay.
And then go find it. So that works. Okay.
But I think the issue is that var a is defined within the scope of foo, so it doesn't exist when bar tries to reference it.
Yes. Yes. That's why it blows up. It doesn't blow up in two places. It just blows up in one.
Okay.
But hang on. Well, let's see if
Yeah, give it a shot.
See if they're undefined there. See what happens if we do this dot a. Undefined. So,
and if you remove that var a equals 2 line, we probably still get an undefined. What if you stuck that var a equals 2 outside of function foo?
It will work.
Yeah, I think so.
Yeah, because it'll have it on the global level. It should work then. RA equals 2. Yeah, you gotta love the fact that you could just pull the console up. Yeah, it works.
Yep. Okay. Cool.
So that's why. Yeah. Okay. You gotta love the fact that you can just pull the console up and there you are.
Yeah. You know, I haven't been a huge fan of that, but it has been extremely handy going through JavaScript. So I'm becoming a fan of it, I guess is what I'm trying to say.
Yeah. And then I gotta figure out how to stop sharing.
I think you are. I think that's me.
Okay.
Can you see my screen?
Yes.
Okay, cool. Okay, so now we're going to talk about how it actually works, which we've already kind of started talking about. But so how does this work? And it says, having set aside various incorrect assumptions, let us now turn our attention to how this mechanism really works. We said earlier that this is not an author time binding, but a runtime binding. It is contextual, based on the conditions of the function's invocation. So basically, this is defined when the function is called and not when the function is defined. Yes.
Right.
Yes.
It's also it's called where, or this is where the function is called.
Yes. Yes. Exactly. Yeah, it says this binding has nothing to do with where the function is declared, but instead has everything to do with the manner in which the function is called. When the function is invoked, an activation record, otherwise known as an execution context, is created. This record contains information about where the function was called from, the call stack, how the function was invoked, what parameters were passed, etc. One of the properties of this record is this reference, which will be used for the duration of that function's execution. In the next chapter, we'll learn to find the function's call site to determine how its execution will bind this. Okay. So yeah, like you said, chapter 2 is all about what this actually is and not what it's not.
Which I found much more easier. I found chapter 2 fairly easy to follow.
Okay, cool. Well, then I will rely on you when we get a little further on because I got kind of confused.
Okay. Hopefully I'm not setting myself up for failure here.
All right, so let's see how we do. So this is created based on the call site. Well, what's a call site? The call site is the location where the function is called and not the location where it's declared, which is essentially what we just said on the last slide, but we're picking up where we left off in chapter 2.
Yes. And they can be the same place. Like the function can be declared on the global object and then called on the global object.
Yes.
If they don't have to be in the same place.
Exactly, which is what makes this an interesting mechanism in JavaScript.
Right.
Okay, so call stack and call site. So here we see some nested functions. We start out with Baz, and Baz calls bar, and bar calls foo, and then at the very end we call Baz.
Right. So Baz is called at the bottom,
Yes.
So it's defined on the global object, and it's also called on the global object.
Right. Right. So all three of these functions are defined
on
the global, but
right.
they're being called in a kind of nested way. So
Right.
so Baz calls bar calls foo. So the call stack at this point, when this first Baz is being called, is Baz. So our call site is in the global scope. And in Baz, we call bar. So let's drop down to bar. Our call stack is Baz, which then is called bar. So our call site is in Baz, meaning, well, you can see it here.
And if you just run this, it's going to do what you expect it to. It's going to print out Baz bar foo.
Yes. Yes.
In that order.
And then we call foo. So our call stack is Baz bar foo.
Right.
Call site is in bar because it's right here in bar. And then it prints out foo. And then we actually do the calling. So it kind of loops back around.
Right.
But we're dealing here with both the compile time and the runtime, which is a little confusing. Yeah. But when we're talking about this call stack, that's not a compile time. That's actually at runtime.
Right. So what's available to us to be called is defined by lexical scope. Mm-hmm. But what this is defined by the call site.
Yeah, the call. Yes.
Those are the two things. Like that's the way I like to draw the distinction. Like when you're defining everything, when you define it, what it has access to and what works and doesn't, that's all set up by lexical scope and or block scope. Mm-hmm. This is all just defined on where you call the function.
Yeah, I like that way of putting it. That makes it make sense. Okay, so call set rule number 1 is default binding. And this is aptly named because it's what happens by default. Mm-hmm. So note that global variables are global object properties, and that in the example here, this A resolves to our var declaration because this refers to the global object and because of where foo was called. So if we look at this here, or if we look at the bit of code here, we define foo. Within foo, we're using this to refer to A. We define A at the global scope, and we call foo at the global scope. And so A is available on this because this refers to the global object scope, global scope. I don't know which term's better.
So I think that something like this gets used in Ruby.
Okay.
Have you ever used pry?
Used what?
Pry.
I don't think so.
REPL in Ruby, Ruby has a REPL called pry, B-R-Y.
Oh, okay. Yeah, I've used IRB, but I haven't used pry.
Okay. So pry has this really useful tool. I don't know if IRB has it or not, where you can require pry in the file, and anywhere in your code you can put binding.pry. And at that location, when the code executes, when it gets to the place where binding.pry is located, it stops the world at that location and dumps everything into a pry session. So you have access to everything that the code has access to right there.
Okay. So that's kind of like in Visual Studio, if you were using something like that, or Java, where if you put a debug stop in, you can then stop your code and inspect everything that's going on.
Yes, but it's scoped to like where that binding has access to.
Exactly. Yes.
So I think maybe that the binding in binding.pry means the same kind of thing here as when we talk about the binding of this. Like this .a is kind of like the same thing as saying binding.pry. It's saying at this spot, you know.
Yeah, I see the similarity because they're both runtime, right? It's not having anything to do with how the code was defined. It's that point in runtime that we're interested in.
Yeah. So anybody who has used binding.pry or some other kind of debugger that's scoped to run, like at runtime, stop the world and see what you have access to, understands kind of intuitively like what's going on here with this .a. It's like when you get to this A call right here, stop the world and look for an A.
Yes. Yeah, exactly. And you're right. It has everything to do with runtime and really nothing to do with the other stuff.
Yeah. Sorry, I derailed, but it was just an analogy that I noticed.
That's good. I hadn't thought of relating it to a debugger, but that's I think a really good analogy. Okay, so one note here, that code is not going to work correctly in strict mode because this will not be the global object, and therefore when we try to refer to it, it's not going to have this A on there. Yeah, exactly.
Yeah, it won't reach up and try to grab. It won't go looking for A on the global level when you use strict mode. That was one of the other things. Remember when we said about strict mode that it won't accidentally define global variables, and you're like, well, what else won't it do? And I'm like, I don't remember. This is one of this is one of the other things that it will prevent you from doing is reaching out and looking for. When you use this, it won't reach up to the global object.
Yes, yeah, and that makes sense because it is strict is basically restricting you from putting stuff on the global object.
Yeah, it kind of
necessary.
Things. It kind of creates like function scope.
Yeah.
Yeah. Okay.
Okay, so it also goes on to say that stuff gets weird if you're using code, like if you have a library or part of your code is in strict mode and part of it's in non-strict mode, so just don't do it. Stick to one or the other.
Yeah. That makes sense. Which means nobody's using strict mode because there's a ton of libraries that aren't.
Yeah.
Would be my guess.
Or if you do decide to use strict mode, there are libraries that you need to avoid.
Right.
Okay, so does the callsite have, or implicit binding, sorry, callsite rule 2, implicit binding?
Right.
So in this case, we have a context object.
Right.
Yep, exactly. So we've created this object, this variable containing an object that has A and foo,
Mm-hmm.
and then when we call foo, it's being called on this object.
Mm-hmm.
And so that
it goes to the object.
Exactly.
Yeah,
so this is then saying, okay, well, I'm existing in this object because I've been called inside of this object at runtime, and therefore I know that A is 2.
So, and I'm pretty sure that would work in strict mode.
Yes, I'm pretty sure it would too.
Like that is the expected behavior. It's like when you're calling this, it's bound to an object that tells the function what this is supposed to be.
Yeah, exactly.
Yeah. Cool.
Okay, and only the top/last level of the object property reference chain matters to the call site. So here's an example.
That confused me a little bit because I think of top like of global level.
Yeah, I do too.
So actually, I think it should have said like only the
lowest
innermost level.
Yeah, I would agree. It confused me a bit too.
So yeah, don't think that when it says. So let's look at what the code's doing, and then we can kind of get that kind of, we can dispel that thing, because when I read that at first I was like, oh, so it's going to call at the highest level, but no.
At object, yeah, exactly.
Yeah. No. So function foo call this dot A. Cool enough. Mm-hmm. You have two objects. You got object 2, which has an A, a 42, and a foo. Yep. And then you have an object 1, which has an A of 2 and an object of 2. And then you call, and I was almost hoping that you would say, what is this going to do? And not show the result. Because this would have been a great chance for that. But so if you call object 1, which has an object 2, and you call dot foo on the object 2, it still uses object 2's 42 because basically it's because it finds that A first.
Yeah, exactly. And it makes sense if you look back here, you have the opportunity to scope to global, but it doesn't because it's bound to this object.
Right.
So following that same
it goes
rule.
to the object that it's immediately bound to.
Yes, exactly.
Yeah.
So it's bound to object 2, and so that's why it looks at the object 2. It's not going to look at here. It's not going to look for global scope. It's going to look for the one that it was called from.
Yeah,
I guess it's runtime, so called from would be here.
Yeah, that seems intuitive to me. That's what I would want to happen.
Yes. Yeah, me too. Okay, so one of the pitfalls of using this is that the call site can disappear on you.
Yeah.
It may not be where you want it to be. So in this example, we got the same function foo that just outputs you this. We create a variable object that has a equal to 2 and foo equal to this foo function. So here
we have a variable that's a global variable, global scoped variable, which calls object.foo, which assigns object.foo to it, but object.foo is just the function foo.
Right, and it's not being called there.
Right, it's just because you don't have the
bracket.
Yeah. So yeah, that's exactly right. Because you're not getting called there, it's not returning the result of the function. It's actually returning the function itself, and so the function
foo is now at a global level
from object. Yeah, it gets decoupled from. Well, it was already at the global level, but what this is gets decoupled from object.
Yes. Yeah, that's a better way of putting it. It's no longer associated implicitly to this object. It's now been just assigned to this variable, which is at a global level.
If you called that without the var a equals oops global, I'm pretty sure it would say undefined.
I would agree.
Yeah. And if not, then that would be a problem. That's not the expected behavior.
Exactly.
But yeah, I could see how it would be really easy to make this mistake.
Yeah, especially if you're like passing a function around to different stuff, and then it didn't do what I thought it was going to do. Why is that? What went wrong?
Yeah, I just forgot to call it the function instead of the return of the function.
Yeah, exactly. So here's an example of that using callbacks, which I think are pretty common in JavaScript. So we set up our foo function. We create this other function that basically it accepts a function and then calls it. So this ends up being our call site. And then we set up an object with the original foo function in it. And we set up a oops global variable a at the global level. And so when we call this kind of function calling wrapper and pass it our object foo, we end up at the global level.
Okay, so let's look at this. Let me break this down a little bit. So
okay.
Foo has this a. Do foo takes an argument and calls the function that's passed in. So the call site is inside of do foo, and since a is not defined for the purposes of do foo, it reaches up to where do foo is defined, which is on the global level, finds the oops global, and so yeah, it's doing exactly the same thing as the previous page.
Yeah, it's just a little harder to see because it's kind of misdirected.
Right.
But yeah, you're right. It's decoupling this assignment to that object. Now, if we passed the object into this function and then called object.foo inside that function, I think
it would work fine.
Yeah.
Yeah.
Okay, so call site rule 3, explicit binding. Functions have call and apply methods that allow you to explicitly specify what this is. So here we have our foo, which I think is the same function we've been using all along. We create this object that is going to have an a equal to 2, and then we can use call and pass it that object, and we're going to explicitly bind that function call to that object so that when we use this, it's going to point to the object that we passed it.
Yeah, so This reminds me a lot of how Lambda works in Ruby.
Yeah, it does.
So you have like a foo. So in this case, foo would be our Lambda.
Mm-hmm.
And it would say, like, we're going to do some logic inside of the block, which is the curly braces.
Mm-hmm.
And then we just, and then we call, so foo is sort of kind of like saying, like, variable name equals Lambda, this block. Hey, welcome. And so then, oh, yeah, we got one more, we got a new person.
Awesome, welcome.
And so, yeah, it's almost exactly how a Lambda would work, except that instead of assigning the Lambda to a variable, it's just saying, it's getting a namespace of foo. And then when you say .call, which is exactly what you do to a Lambda, you say .call and pass it an argument, it uses in this case, it uses the object being passed in to define the variables for the block.
Yeah, it's almost like it's taking this this rule 2 where we call it from inside of the object, and it turns it inside out with this call, because we're still we got a function, but we're not actually using the parentheses to call it. We're using this call method that's on that, and then passing it the binding, I think is the right word. So we're binding that function to this object in the call itself using call, or I think they said apply would work as well.
So this seems totally intuitive and like how you should do it.
I would agree that this seems to be the
explicit.
Exactly, because you're not going to run into the pitfalls of what exactly is this scope to, because every time you use it, you're going to be saying I want or not scoped, wrong word. What is this going to be bound to? Bound to it.
Yeah. What's the call site?
Yeah, exactly. What's the call site?
Yeah. Like you explicitly know what the call site is. You don't have to like intuit what the call site is. You don't have to go looking for it.
Exactly. It's right there.
Yeah. I like that.
Unfortunately, explicit binding alone does not solve for functions losing call site. But this variation does. So, and it's called hard binding. So this, up until this point, is pretty close to what we saw before, right? Where we create an object and we're using call, we pass it the object to bind it.
It puts the call inside of another function this time.
Yes, exactly. It's just putting that inside of another function. And then when we call that other function, bar is hard binding foos this to the object.
Yes.
I'm not sure I completely understand that.
So let's see. I'm going to look at the text real quick, if that's okay.
Yeah, that's fine.
Let me pull up the right chapter here. Here we go. So we create a function bar, which internally manually calls foo.call object, thereby forcibly invoking foo with object binding for this. Okay. No matter how you later invoke the function bar, it always manually invokes foo with object. This binding is both explicit and strong, so we call it hard binding. So it just says, like, no matter what you do to bar, the foo.call object is always going to be bound properly. You can't lose the binding for foo.call object.
Okay, so you might, if you didn't have that bar there, you might just accidentally call foo the wrong way at some point.
Yeah. Well, or you might like, you can't. Now those two are bound together, period. Like bar, like foo, if you call bar, it's always going to do foo.call object. It's always bound to it.
Okay. So it's kind of like a wrapper for that explicit binding, and once that wrapper is created, as long as bar is in scope, you can then do it explicitly because it's already set up.
I wonder, this is what I wonder.
Okay.
If you do, because this is actually calling, when you call bar, it actually calls the function. Yes? No, it just defines the function. But foo.callObject, I wonder if this creates a closure over the foo and the object, and if you go on to later change foo or the object, I wonder what the behavior, I wonder if it changes the behavior inside a bar.
Well, I don't want to think about that. That's I don't know.
You see what I'm saying?
Yeah, I do.
But okay, but then anyway, the set timeout bar 100 always works because then you do bar.call window. Okay, all right, yeah. See, I'm not used to doing stuff on window and calling window, but that all makes sense.
Sort of. Yeah. I mean, I think that seeing this, that if I ran into the situation, I could say, oh, okay, so I need to do this hard binding thing.
Okay, let's look at this. The most typical way to wrap a function with hard binding creates a pass-through of any arguments passed and any return values received. So, yeah, function foo something. Okay, yeah, I think that's going to be the next slide, isn't it?
Yep.
Yeah, function foo something, console.log. Hey, fellas. Got two of them on. They're both on mute, though. So function foo something, console.log this.a something.
Mm-hmm.
Return this.a plus something. Okay. So is this all one? Oh yeah,
This is two different ways of doing it.
Two different ways of doing it. Okay.
Yep.
So
this
let me
one,
look at the one on the left.
Yeah, this one is simpler. This one is made to be more generic.
Oh, okay. All right. Yeah. So we got a foo. It takes an argument. Logs. Calls a.
Mm-hmm.
With something. So when we call foo, where's foo getting called? Foo.apply object and arguments. What are arguments?
Arguments is going to be this something. We're going to call it down here with an argument.
Oh, three. You give it 3 down there, yeah.
And that gets passed through and gets this 3 here.
Yeah, so it becomes 2 plus something equals 5. Yeah. Okay. All right, that makes sense.
Okay, and this is a variation on that, except that we've got this bind helper here. So instead of explicitly saying we're going to apply apply with foo, this is just going to do a hard binding on any function. And
so yeah,
objects.
This is an example of what I was talking about, how because you get closure and you get these self-references, you can start writing code that writes code. Any kind of function that you pass inside of here with an object, it's going to bind them for you.
Yes, exactly.
Spits out the other side you could just assign
bind
those,
here.
Yeah, you could just sit there and you could say like 10 times do, or the JavaScript equivalent of that, var I equals bind foo dot, foo dot object, and you can have object be like a equals I.
Yeah, or you could have that object be a list of objects that all had something, and then apply that function across all of the objects.
Yeah, that lets you dynamically generate bound functions.
Yep.
So that's cool and powerful.
It is, and it's also built into ES5. There's function prototype bind. So instead of having to write this out, if you're using ES5, then you can just use foo.bind, and it'll bind it to that object for you, and then it does the thing.
Nice, powerful, useful.
Yep. Okay, so last call site rule is new binding. The new keyword in JavaScript is not the same as it is in object-oriented languages, and this confused me a little bit. I wasn't really sure what was going on with this. But when a function is invoked with new in front of it, otherwise known as a constructor call, the following things are done automatically. So first, a brand new object is created or constructed out of thin air. The newly constructed object is prototype linked.
Okay.
The newly constructed.
What that means in a minute.
Yeah, I'm not too clear on that.
Okay. Yeah, we'll get to it.
The newly constructed object is set as the this binding for that function call. So that
Okay.
part makes sense because we're doing a new binding.
Right.
And unless the function returns its own alternate object, the new object or the new invoked function call will automatically return the newly constructed object. So
Okay.
steps
So
one.
when you create a new object, you
Uh-huh.
create a new object out of thin air. That seems fine. It's how do I put this? It's not inheriting. It's creating a new object, I think.
Okay, but it's a function.
So, yes, but you have to remember that functions are also objects.
Okay, here's an example we can look at while we're
Yeah.
through it.
So function foo is an object also.
Okay.
Yeah. So consider this function foo a takes an argument this dot a equals a. Okay. So var equals new foo 2. So this dot 2 equals 2. So foo dot 2 equals 2. Or bar dot 2. Bar dot a equals 2. Okay. Oh, okay. Yeah, no, I get it. It's creating a key value pair there. Okay. All right. Yeah.
So what's going on here?
So, okay, you have a function, foo, that takes an argument of a.
Okay.
And then it passes that to the block, and it says this dot a equals the argument passed.
Okay.
All right.
So the call scope or call site dot a is equal to whatever parameter got passed in.
Right. And then so we say var bar, so variable bar equals a new instance of the foo function with the argument of 2. So that means that the bar object, the variable that references our new foo function, has a dot a defined on it with whatever argument we passed, which in this case is 2.
Okay, when we use that new to define a new foo function, does foo still have this code inside of it?
Yes, it's using that code.
Okay.
It's saying it's a new instance of the object foo.
Okay.
Or, well, not even an instance. That's not right. Instance is wrong. I'm speaking in Ruby. It's a new constructed prototype of foo.
But it's not foo, but it is foo.
Well, so
it's bar.
Go back to the previous page, to the 4 rules. Because we can, now that we've looked at code, we can kind of. So a brand new object is created. A brand new foo object is created. It's constructed. All right. This newly constructed object is a prototype. So it's like prototype function foo or whatever. Okay.
Okay.
And then this newly constructed object is set. This object is set as the binding for this, the function call. So it's like create this anonymous object that like kind of sits in the middle and bind the logic of foo to this anonymous object and then assign all of that to bar.
Okay. Yeah, it ends up in bar. That makes sense.
Yeah.
And
so whenever you
just like
new
foo,
it's not actually foo. It's like a new prototype object. It's just like this like anonymous object that gets the foo. It gets the logic of foo.
Okay.
But it has the scope of it itself. And so like this call inside a function points at that anonymous object, and then that gets assigned to bar. And so that means that bar.a returns the object. I think that's right.
So let me see if I understand this. So we create we define a foo function. It receives a parameter a, and it is going to set this dot a equal to the value of that parameter.
Right.
And then we're going to say make a new foo. So that's going to be just like this foo, except it's not foo. It's undefined at this point as far as the name.
It's when you say new, it's like create a new, like, we'll just say, I'm going to say anonymous prototype object until I hear somebody tell me that's wrong. Like,
Okay.
just create this new object out of thin air. Don't call it anything. Just create it out of thin air.
Okay.
Take the foo function and like put the foo function as part of that object, and then make the this reference the anonymous object.
Okay. Okay. So this, when we pass this 2 in, this is referring to this the anonymous object.
Yeah.
We're going to set the A property of that anonymous object equal to 2.
Right.
And then dump the result into this bar variable.
Right, and that makes bar the name for the anonymous object.
Yes. So now we have a function bar that accepts a parameter, sets some stuff, but it also has A set equal to 2, which is why when we console log out,
yes,
I think
that's right. I could possibly be wrong, but I think that is what this is saying.
Okay. Okay, I think I understand. And so if we put a line here in between these 2 lines, and we called bar with a parameter of 3, when we called console log, it would come out 3. Because it would be setting A within bar equal to 3.
Well, so now bar is not the function foo. Bar is an object with the A key that returns the value 2. Because look, foo gets called when you do the new. See, when you do new foo 2, foo's getting called.
So you can't call bar. Or can you?
I don't think so. You could try it. Try it.
All right.
Pull it. Hit Control Shift I and try that stuff. We're looking at the code right here. Yeah, go back one screen. There you go. So
okay,
do function foo A. Just do exactly the same code.
Function. What the? Okay, so function foo A.
This dot A. You're gonna have to hit Shift I when you do that. I think.
Do this. A.
Yeah, you can do that. Equals A.
Okay, so now
and then
bar equals new.
And now if you look here, this is where foo gets called. Right here. Syntax error.
Oh, I said now, not new.
Oh, yeah, okay. So if you look right there, this is the line where foo actually gets called.
Right.
So foo is returning this dot A equals 2. And then this dot A is getting assigned to bar. So if you look at what bar is, just do console.log bar and see what's defined on it.
It's an object.
With an A2. Yeah, it's an anonymous it's just an object with an A2 defined on it.
It's not a
function. It does not have foo at all. It doesn't have foo at all.
Oh.
Yeah.
Weird.
Foo gets called. So it's returning. Foo is returning. Foo gets called when you say new foo 2, and foo is returning this dot A equals A. It's returning the whole thing.
And this is why you can define. Yeah.
Yeah.
This is why you can define properties on a function, because that function can have new called on it and become an object. And then that object will have those properties.
Well, so no. The new is saying new object with the function foo and the argument of 2 called. Like give me a new object, and the things I'm defining on the new object are what the call of function 2 with the argument, or what the call of function foo with the argument of 2 returns. And
Okay.
the foo argument is returning the entire this.a equals a line. And it's assigning all of that to this new object. And saying object.a equals a, which is 2 because we called it with an argument.
Okay. I think I get this.
Yeah.
It's kind of strange, but
yeah,
I
agree. It's nuts, but it's nuts because it's new to me. It's not nuts because it doesn't.
It makes the combination of this and the new makes an object, but it's a function creating that object.
Yeah, you're used to new being instances of class objects. This is something else entirely.
Yes.
This is like some new magical object that I pluck out of thin air that's completely anonymous, and I'm calling a function to tell that object what its values are going to be, what its key value pairs are going to be.
Exactly. Which is not something I've ever done before.
No, me either. This is not how I'm used to this. But I mean, I'm sure that this gets used, and I'm sure it's useful. I just have never done it.
So this is what they're talking about when they say that JavaScript has prototyping.
So we're starting to touch on prototyping.
Okay.
One thing to notice about this is when it says new here, this is not a new instance of an object defined by a class. This is a new object.
New object defined by a function.
Well, no, it's just a new it's just this new object.
Okay.
So one thing that we'll get into in 2 weeks is that objects and prototypes, prototypes do not have like so like in class classes you have the class and then you have an instance of the object created from the class.
Right.
That is not how prototypes work.
Okay.
Prototypes are the prototype is defined and you make literal copies of the prototype. And so I'm guessing that what new is called in here is a literal copy of the anonymous prototype object.
Okay. That's interesting.
Yeah.
So at this point, I was completely confused, and I pointed to the book when it starts talking about how these rules apply. So
let's look at the book then, at how the rules apply, because that's important. Let's see, API call context, new binding.
Everything in order. It's about halfway down.
Yeah, here we go. So is this where your slides in?
Yeah.
Okay. All right. So you've got everything in order pulled up on the screen, so we can kind of see what I'm reading here. So there are 4 rules.
Mm-hmm.
All you need to do is find the call site and expect it to see which rule applies.
Okay.
But if the call site has multiple eligible rules, there's an order of precedence. The default binding is the lowest priority, and then
okay. And when we say priority, which one has the highest priority?
Explicit takes precedent over implicit.
Okay. So it's kind of reverse of the order we learned them in is 4, 3, 2, 1?
Yeah, I think so.
So first would be new, and then would be explicit, and then would be implicit, and then would be default.
Yeah.
Okay.
So yeah, new is all, yeah. So here we go, determining this. It gives the 4 orders to look at. Is the function called with the new binding? If so, this is the newly constructed object, always.
Okay.
Is the function called with call or apply, which is explicit binding, even hidden inside of a bind of hard binding? If so, this is the explicitly specified object, which is the object passed with the call or the apply.
Okay.
Is the function called with implicit binding? Then, if so, this is the context. And then finally, if none of those previous ones apply, it just does default binding, unless you have strict mode, in which case it's undefined. If it's global.
Right. If it's global, yeah.
Right.
Okay. Okay, that makes sense. Looking at them in order, so new, explicit, implicit, default. It's going to look first at new, and then explicit, then implicit, and then default binding.
Yeah. So, and then, okay, we have exceptions to the rules, of course.
Of course.
If you pass a null or undefined as this, those values are effectively ignored for when you do call, apply, or bind. And instead, the default binding will apply.
Okay, so if you explicitly bind or implicitly bind to, or can you implicitly
so if you
bind?
pass a null in, when you do like foo.call and you pass a null, it's going to do default binding. It ignores it.
Okay, because it can't bind to null.
Right.
Okay, that makes sense.
So it says, why would you intentionally pass something like null for this binding? It's quite common to use apply for spreading out arrays of values as parameters to a function call. Similarly, bind can carry parameters, preset values, which can be very helpful. So you can have an array with nulls in it, and if you try to bind it, then it just ignores it.
Okay. Interesting.
So, and of course, as he says, like these can lead to very difficult to diagnose and track down bugs.
I can imagine.
So, and then we have a safer practice. Somewhat safer practice is to pass a specifically set up object for this, which is guaranteed not to be an object that can create problematic side effects in your program.
Okay.
Following terminology from network and the military, we can create a DMZ object. Nothing more special than a completely empty, non-delegated object, which is, it says it'll talk about in chapters 5 and 6. And if we always pass a DMZ object for ignored this bindings, we don't think we need to care about. We're sure any hidden, unexpected usage of this will be restricted to the empty object, which insulates our global object from side effects. It's just a wrapper that protects your global object from getting infected with weird-ass behavior and variables you want to get.
Yeah, that seems like it would be good practice.
Yeah.
Although I'm not sure when I would necessarily use it at this point, but I guess that comes with a little practice. Okay, so, and then finally it looks like indirection, or maybe not finally. Another thing to be aware of is you can intentionally or not create indirect references to functions. And in those cases, when the function reference is invoked, the default binding rule also applies.
One of the most common ways indirect references occur is from an assignment. So function foo console.log this.a, variable a equals 2, variable o equals an object with a equals 3 and foo, and then variable p equals another object with a assigned to 4. And if you say o.foo, it's going to call this.a, which would be 3. That makes sense. If we say p.foo equals o.foo, it's going to return 2.
How did it get 2?
It loses
because this is global. So it's binding.
It loses its binding, and
that's
and because it loses the binding, and because foo's being passed as a function, not as a called function. It's not returning foo, so that when you call it, it's cutting called on the global level and losing. And so that's bad.
That seems tricky to find if you were. I mean, probably not the best thing to do, but it seems like it would be a tricky bug to track down if you didn't know what was going on.
Yeah. Let's see. We saw earlier that hard binding was one strategy of preventing function calling. Back to the default binding. we can construct so-called soft binding utility, which emulates our desired behavior. Provide a default for default. So we get to provide a default for a default binding that's not global or undefined, while still leaving the function able to manually bind stuff. So we have like.
Okay, so if we don't want default binding to point to the global call site, we
also don't want it to point to like an undefined or null object. We can have it point at like this other thing, which seems like a lot of code.
It does, but if you were to call a null, it wouldn't go to default binding. It would go to whatever we set up in this soft binding instead.
Right.
Okay. Seems like pretty complicated stuff. But I guess I could see where that's useful, where you're like, don't put this at the global level. I want it to go here. Almost like a method missing in Ruby.
Okay. Yeah, kind of. That sounds right. So, okay, now lexical this. Normal functions abide by the four rules we just covered. But ES6 introduces a special kind of function that does not use these rules, the arrow function. Arrow functions are signified not by the function keyword, but by the hash rocket, or fat arrow operator. I'm used to calling that a hash rocket. I'm used to calling it a hash rocket because in Ruby it's for hashes.
Yeah.
Instead of using the four standard this rules, arrow functions adopt a this binding from the enclosing function or global scope. Interesting. So it explicitly does use global.
Huh.
So we have function foo, and it returns an arrow function. This here is lexically adapted from foo, console.log this.a. So it's always going to return. So if we do var object equals a2, var object 2 equals a3, bar equals foo.call object 1, that's going to give us 2, it assigns 2. And then we saw bar.call object 2 gives us 2, not 3.
Even though we're calling it explicitly with object 2, we use this thingy, fat arrow, and so it's stuck with 1 somehow.
Yeah, okay, so the arrow function in foo lexically captures whatever the foo's this is at its call time. Since foo was this bound to object 1, bar, a reference to the returned arrow function, will also be a this bound to object 1. The lexical binding of an arrow function cannot be overridden, even with a new.
Okay.
So most likely use case will likely be callbacks, such as event handlers or timers. We have a function foo set timeout. This here is lexically adopted from foo, console.log this.a. So the object equals a2, foo.call object is always going to be 2, no matter where you assign it.
Sounds like they wanted a quick way to kind of simplify this whole thing. And they used that arrow thing.
Yeah. It binds it hard. Yeah, it does the same thing as hard binding, but instead of hard binding it to bypassing it into a function, that like hard binds it there, then it hard binds it by using the hash rocket.
Yep. And since you're probably going to be using this most often for callbacks, then that's good because we want to hard bind it to the scope or the where we defined it and not to where it's being called later on.
Right, exactly.
Okay, that makes
while arrow functions provide an alternative to using bind on a function to ensure it's this, which can seem attractive, it's important to note that they essentially are disabling the traditional this mechanism in favor of a more widely understood lexical scoping. pre-ES6, we already have a fairly common pattern for doing so, which is basically almost indistinguishable from the spirit of ES6 arrow functions. So the var self equals this.
So we're assigning this to a variable.
Yeah, it's just manually, it's just one extra step. I don't know what. Yeah. This guy has a big problem with change.
Yeah.
It's like we could do the same thing with one extra line of code that we have been for years. Oh, okay.
This is just a shortcut for that.
Yeah.
Yeah. Okay.
So while self equals this and arrow functions both seem like good solutions to not wanting to use bind, they're essentially fleeing from this instead of understanding and embracing it, which I could understand, especially with callbacks.
Yeah, I was going to say,
I don't. Yeah, callbacks can be hard to debug.
Yeah.
If you find yourself writing this style code, but most or all of the time you defeat this mechanism with lexical self equals this or arrow function tricks, perhaps you should either, one, use only lexical scope and forget the false pretense of the this style code. That seems reasonable. Mm-hmm. Or embrace this style mechanisms completely. Also reasonable.
So I got to think.
Go ahead. Don't use this unless you're actually going to use this.
Yeah. I got to think that in something like Node, where you've got JavaScript running on the server and on the client, that like the hash rocket style has got to be easier because you're not going to have some weird callback thing going on when you pass between the client and the server.
Or you just use like block scope let function shit, and then you're always safe because you're doing with lexical scope and block scopes. Yeah. And you're not having to keep track of this at all.
Yeah. This seems like it's confusing. I mean, I understand what we've gone through, but I would think that if you use it extensively, then you could make some difficult to read code.
Yes, I would think. But if you're using it extensively, you could also probably do some meta programming that's difficult to do otherwise.
Yeah, I would agree.
Where you're taking advantage of things like closures with this to really do some powerful stuff.
Yeah, that sounds about right.
So CLDR called with new is the newly constructed object. Called with call or apply, use the specified object. Called with context object, owning the call, use the context object. Default, it's undefined in strict mode, otherwise it's global object.
Okay.
And then be careful of accidental unintentional evoking of the default binding rule. In cases where you can safely ignore a this binding, a DMZ object, where you want to safely ignore this binding, a DMZ object like omega equals object.create null is a good placeholder value that protects the global object from unintended side effects. Instead of the 4 standard binding rules, ES6 arrow functions use lexical scoping for this binding, which means they adopt the this binding, whatever it is, from its enclosing function call. They're essentially a syntactic replacement for self equals this.
Okay. Cool. Yeah, thanks for sorting that out. That helps.
Yeah. Okay. So that was interesting, but I'm glad I don't think I'll end up writing a lot of JavaScript that uses this.
I would agree. I don't see myself embracing that right away.
Well, I don't see myself needing it because I don't see myself writing a bunch of JavaScript that uses like fancy, closure stuff.
Yeah, I'm totally not ready to write JavaScript like that anyway. I mean, maybe if I'm using a library that forces me to do it, then I might do it, but I don't see myself going out of my way to try doing tricks with this.
Right. Okay, so 2 weeks from now, are we going to cover the whole chapter, or are we just going to cover the one chapter?
I think, from what you said, I think chapter 3 is probably a good, just by itself.
Let's see. Well, let me look at what chapter 4 and 5 are.
Okay.
4 is pretty long on its own. 5 is even longer, and 6 is even longer. Why don't we try to do 3 and 4, and then we'll do 5 and 6, and I'll do the slide. And we can, if that's too much, we can always break it up. But we have 2 whole weeks, and I'll do the slides for it.
Okay.
So let's try to do 3 and 4.
Sounds good.
Because that'll get us up to prototypes, and we'll be ready for prototypes then after next week.
Yay. Right on.
Which I think after we get done with prototypes, that'll be when we take our break and just do another book, right?
Yeah, what are the final 2 books? Or 3 books, however many books.
See, there's types and grammar,
okay.
Async and performance, and yes, 6 and beyond. I think the types and grammar would be useful to cover, but I don't know that async and performance is something you need to worry about unless you're really like.
Yeah.
It has callbacks in it, so that's useful.
I think async might be interesting. Performance at this point, I don't really have much use for because I'm just going to try to get it working.
Yeah, but it actually has 4 chapters that are stuff that is not those, or not that topic. It says asynchrony now and later, callbacks, promises, generators, and then it gets to performance and benchmarking. So maybe we could look at that one later.
Yeah, generators.
ES 6 and beyond. It's got a whole chapter on metaprogramming in there. But to be honest with you, I don't think I'm going to need any metaprogramming in JavaScript. The less programming I have to do in JavaScript, the better. Did I say that on a podcast or on a call about JavaScript? So yeah, I don't see myself needing metaprogramming anytime soon. But yeah, I think we definitely need to get up through the prototype stuff and then probably types and grammar.
Yeah, for sure. And if you're out there watching this and you want to see us go through those other books, then join in the hangout and let us know.
Oh, yeah. Types and grammar has a whole chapter on coercion. We got to cover that.
Okay.
Because you can't get through a book on JavaScript that has a chapter on coercion without covering the chapter on coercion.
Fair enough.
Because that's like such a big thing in JavaScript. So, yeah, we'll take a break, do another short book, and then we'll come back and do types and grammar and maybe parts of the 5th book.
Did you have another book in mind?
No. Maybe we can talk about that next week, 2 weeks from now when we come back.
Okay.
Cool. All right, man. Well, you have a good night, and thanks for coming in, guys.
Yeah, thanks, Joseph Bass. Thanks for coming in, and hope that you enjoyed it.
Y'all have a good one. We'll see you in 2 weeks.
In 2 weeks, yep.